Finding missing lengths using basic trigonometry with adamonlinetutoring. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. There are some trigonometric ratios that exist within right-angled triangles. We can use these to help us find missing lengths or missing angles. A mnemonic which will help you to remember the trigonometric ratios is the word SOHCAHTOA, spelled SOHCAHTOA. And we can use triangles in the same way we would for our speed, distance, time or density, mass, volume triangles, where sine is equal to opposite divided by hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. To help us identify which ratio we'll be using, sine, cosine or tangent, we need to be able to label the right-angled triangle in reference to the angle provided, where the length opposite this angle will be labelled as O, or opposite. The length opposite the right angle is always the longest length labelled as H, the hypotenuse, meaning the other length, which is next to the angle, is labelled as adjacent. Circling the one that's been given to us and the one that we're trying to find will highlight which ratio needs to be used. In this case, the opposite and the hypotenuse are needed for this question, meaning it will be the ratio that involves O and H, which is the sine ratio. Drawing your triangle and highlighting the part we're trying to work out, which is the opposite length. This tells us what we need to do with the other two bits of information. We have sine in the bottom left, so we need to find sin, used for short on the calculator, and this will open up a bracket. And we always attach the angle to the ratio, sine of 58. Don't forget to close the bracket before we multiply by the hypotenuse, or H, because it's written next to it in the triangle. So sine of 58 multiplied by 11 is 9.3285, and rounded to three significant figures, placing my line after the third important digit of 2. Would be 9.33 centimeters. On to the next question, and labelling the triangle in reference to the angle of 11 degrees given. This would be the opposite side. The one opposite the right angle is the hypotenuse, meaning the one next to it will be labelled as the adjacent. The length given to me is the adjacent, and the one that I'm trying to find is the hypotenuse. The ratio that involves A and H is cosine. For this question, I'm trying to find the hypotenuse, and this time notice that A is on top of cosine, or cos for short, meaning I need to take the adjacent side, 4.5, and divide it just as we would with a fraction where you have A over C, adjacent divided by cos, and again we attach the angle of 11 degrees. On my calculator, that's 4.58422. which to three significant figures will round to 4.58 centimeters. Lastly, I'm finding the side marked P. This 6 centimeter side would be the opposite. The one opposite the right angle is the hypotenuse, meaning P should be labelled as my adjacent. The length that's known is my opposite, and the length that I'm trying to find out is the adjacent. The ratio which involves opposite and adjacent is the tangent, or tan for short. And for this question, I'm finding the adjacent. So cover this part up, and that tells me that I need to do the opposite, which is at the top of the triangle, divided by tan of the angle, which is 37 degrees, 7.96226. Rounded to three significant figures is 7.96. On to the intermediate question. With a slight increase in difficulty, we need to find the missing length n correct to 2 decimal places. Notice how n is the length that goes across the bottom of the whole triangle, but the diagram does show us how this triangle can be split to form a right-angled triangle, which will be helpful to find a missing length like this one here. Using the angle provided of 51 degrees, I can label the unknown length opposite, the one opposite the right angle, as the hypotenuse, meaning this one next to 51 would be labelled as the adjacent. I've got the hypotenuse, and I would like to work out the opposite so that I can then use this to find the total length n. The ratio that involves opposite and hypotenuse is the sine ratio, and covering up the opposite shows me that I'll need to take sine of my angle of 51 and multiply this by the hypotenuse, which is labelled as 12. This is equal to 9.32575. Since these two lengths are labelled as the same and they share a height, that means that these two lengths across the base must be the same. So if I know that one of them is 9.32575, the other one would also have to be the same. So multiplying my answer by 2 will give me both of them combined, 18.6515, and correct 2 decimal places would be 18.65. On to the advanced question, one of the trickiest questions that you're likely to find on this topic. The diagram shows a quadrilateral. Calculate the length of CD, giving our answer to 3 significant figures. Whenever you have a larger or a compound shape made up of smaller shapes, in this case 2 right-angled triangles, you'll normally have to start from one side and work your way towards the final answer, which is towards CD in this direction. So it's quite likely we'll have to find and use some information from this right-angled triangle on the left-hand side to then help us with the triangle on the right-hand side. Notice that this right-angled triangle has no angles given or ones that we're trying to find. It's always useful to find a shared length between the 2 triangles, this length here, and the other 2 lengths have been given to us, meaning we can actually use Pythagoras' theorem to help us find the unknown length. Notice how the longest side has been given to us, so I can find the shorter length by doing the square root of the hypotenuse squared minus the other shorter length squared. This is 4 root 7. Keeping this as an exact value will help us avoid any rounding errors. So the length BD is 4 root 7. We can then use this shared length to help us with the triangle on the right hand side, highlighted orange, which will help us to find the length of CD because we've been provided with an angle. We've just worked out the opposite length is 4 root 7. I'm trying to work out the hypotenuse, meaning this side next to it would be the adjacent. The opposite is known and the hypotenuse is trying to be worked out. The identity that involves opposite and hypotenuse is sine. I'm working out the hypotenuse, so I need to take the opposite length, 4 root 7, and divide this by sine of the angle 40, which is 16.4642. Rounding this to 3 significant figures would place my rounding line after the 4, leaving me with a final answer of 16.5 centimeters. Here's a question that I've completed already. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are, or write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.